Cyber-physical attacks are not really that difficult to define. The key idea here is that, or the key logic here is that we define them based on the impact, so where the impact is. So in the past, we would have attacks in cyberspace that would be expected to have an impact in cyberspace. So that was almost a given. Let's say that you would have a denial of service attack where you would have multiple computers being compromised in cyberspace, and these multiple computers would be then used in order to send simultaneously a large volume of meaningless traffic to a target so as to affect its availability, so as to make it unavailable. So you would have an attack starting in cyberspace affecting cyberspace again. Now, in physical space, we would have equivalently an effect in physical space, or that's how we would see it. So we have cyber attacks and physical attacks, and that's all, and that's fine. But we can start adding arrows there. So we can start adding arrows from, let's say, physical space to cyberspace, or from cyberspace to physical space. So if we do this, we can have a physical cyber attack, which is an attack originating in physical space and having an impact in cyberspace. So cutting a cable would affect the cyber availability because we would not be able to connect to the internet, let's say, or we would not be able to transmit information. So there is a physical attack that does this. And similarly, we can have a cyber attack that has an impact in physical space. So if a cyber attack, for example, disables a camera, then the result is physical because we cannot see the image anymore. Or if it affects a valve or it affects a robot and the robot, for example, veers off the route, then that is an attack in physical space. We can also have, and this is what is considered often in the physical security community, we can have attacks that originate both in cyberspace and in physical space, and the physical security community tend to refer to this as blended attacks. So attacks that used to be physical but now are assisted by a cyberspace, a cyber attack. So, as a definition, a cyber-physical attack is a security breach in cyberspace that affects adversely physical space. And it is not like this was not always the case. It is not like we didn't always have an impact in physical space. But I think that the first time that I see it mentioned in popular culture is in the 1960s in the original film The Italian Job, where the thieves have installed a piece of software or have replaced the software of the control room for the traffic control in the city of Turin, and the result is that they created they create a traffic jam, a chaos in the roads of Turin, and this is what the thieves exploit so as to escape with the money. So this was 1960s. So if we want to structure now from now on what we talk about in terms of cyberspace security, in terms of cyber security, then we can use the standard CIA attributes that are used in security, and we start with confidentiality, which is about ensuring that information can be accessed only by those that are authorized to access it. So no one who is unauthorized would be able to see this information or grab this information. If we lose a CD, for example, and this is unencrypted, and then someone can read the CD or copy the CD, then we have a security breach in terms of the confidentiality of the data in that CD. If we have, then we have integrity as a cybersecurity attribute. Integrity is about ensuring that the information is not just accessed, but cannot be modified by anyone who is unauthorized to modify it. So if someone, for example, changes a website, if they do a website defacement attack, then they have affected the integrity of that website. Or if they change some kind of value in a database, then they have affected the integrity of the data in that database. And there is availability, which is about ensuring that those authorized to access something, they can indeed access it. So there is no one who would prevent this from happening, and this is called availability. So we have CIA, it's rather easy to remember the first three, or the most important three: confidentiality, integrity, and availability. Now to this we can add many more. We can add authenticity, accountability, non-repudiation, and other attributes. I find these that are increasingly overlapping, and from the perspective of defining cyber-physical attacks, they don't help that much, but for the sake of completeness, let's add that authenticity is about ensuring that something is authentic. For example, the digital signature that someone uses to sign a document is the authentic signature for them, that they are indeed the people who authorized it or who made it. Accountability is about ensuring that we can trace back who did something, the entity behind an action. And non-repudiation is about ensuring that no one can say that they didn't do something. So if someone has signed the document, they cannot say, well, I didn't sign this document, or this document is not mine. And there are other overlapping, in my view, security attributes. But the most important, the ones that we can work with in terms of cyber-physical security, are confidentiality, integrity, and availability. So CI and A. And some massive text here, but let's take them one by one. Some security terminology that might be of use in the following is that a vulnerability is some kind of weakness in a system that allows the system to be exploited. So we can violate its security, let's say its confidentiality, integrity, availability, and so on, because of the existence of this flaw. This is extremely common in Internet of Things devices, so in smartwatches, in cameras, web cameras, all of these things. They tend to have multiple weaknesses in terms of their security design, in terms of their system design, and this can be exploited. The fact that they can be exploited makes them a vulnerability, makes these vulnerabilities. We then have threats. This is any circumstance or any event that has the potential of exploiting the vulnerabilities we talked about. Then there is the attack, which is actually doing it. It's not anymore a potential, but the attack is the act of a threat materializing. And we can have an active attack or a passive attack. An active attack is one where we have some kind of modification, some kind of altering of resources, so the operation is affected in a way. A passive attack is one where the operation of the system is not affected. So for example, if we eavesdrop on someone's data and we do it in a way that doesn't affect in any way the system, then this is a passive attack. But if we make some system unavailable, then this is an active attack. And then we have intruders, adversaries, attackers, cyber attackers, crackers, hackers, all of these meaning the same thing, which is the person, the individual, the human being behind an attack. And countermeasure being any kind of action, any kind of system, device, any kind of process, technique, procedure that we install, that we set up in order to oppose the threat, the vulnerability, or the actual attack. In the case of an attack. So the purpose of a countermeasure might be to prevent something, it might be to eliminate it, or it might be to minimize its harm if harm is not possible to be prevented. Now that we have some idea about the different types of security attributes that have a significant impact, at least in cyber-physical security, then we can see how we can decompose, in a sense, cyber-physical attack. So we have on the left someone hacking away in cyberspace, so using their computer or any kind of computing device in order to breach the confidentiality in cyberspace, or breach the integrity in cyberspace, or breach availability. Now the logic of this is that any kind of physical impact, in order for this to be possible through a cyber attack, there needs to be some kind of computing system in between. So there needs to be a cyberspace first order effect, in a sense. Now this effect in cyberspace will be, as is always in cybersecurity, something along the lines of CIA, or perhaps the rest, non-repudiation and so on. But it will be primarily confidentiality, integrity, or availability of something in cyberspace. So in order to affect a valve, a switch, a camera, the traffic lights, a car, a drone, and so on, we first have to affect the cyberspace where there is a control of this physical space, of this physical object. The breach of confidentiality in cyberspace can only have an effect in terms of the physical privacy. So we cannot have an active impact in physical space if we have a breach of confidentiality, but what we can have is an impact in terms of the physical privacy. So what does that mean? It means that if someone thinks that they are in their privacy of perhaps the privacy of their home, or in a private space where people cannot normally see them, well, if there is any kind of object there, like a camera or a microphone or any kind of sensing device, the confidentiality of which can be breached, then effectively it is their physical privacy that is affected. So we can have breach of confidentiality in cyberspace affecting physical privacy in physical space. In terms of actuation, in terms of affecting more than passively the physical privacy of an individual, but then we can affect actuation, we can have an actual impact in actuation, then there needs to be a breach of system integrity or of availability. If we have a breach of system integrity, it is possible to first of all have a breach of physical privacy, but also we can have unauthorized actuation, we can have incorrect actuation, we can have delayed actuation, or altogether prevented actuation. So this is possible if the integrity of the system is breached. So if someone not only steals information, but is able to change information or change somehow a computer system that controls a physical system. So if someone affects the control system, the computer system that controls the camera, then they can move the camera. They can use the camera to eavesdrop on people, or they can speak through the camera, or they can even delay the footage coming from the camera or prevent it altogether. And then we can have a breach of availability, which cannot lead to unauthorized actuation or breach of physical privacy, but it can lead to incorrect actuation, it can lead to delayed actuation, and can also lead to prevented actuation. So how would that be possible? Well, if for example this camera is connected to a Wi-Fi router at home and we affect the availability of that router, then we will not be able to connect to the camera, which means that we will have affected we might prevent the actuation. The actuation being, let's say, controlling the camera, like moving it or speaking through the speakers of the camera. And going back to a lot of text, I have some examples here of each one of these 5 types of physical impact. So in terms of physical privacy, this is about breaching the confidentiality of someone's privacy. So for example, the real-time blood sugar level, if they're wearing some kind of implantable medical device that is measuring this, or the number of occupants in a house. If we know how many occupants in a house, then we have breached the physical privacy of that house. There can be unauthorized actuation when there might be unlocking of a door in a smart building, or changing the direction that the surveillance camera is looking at. And we can have incorrect actuation. So in this case it would be if one lowers the speed values reported by car sensors, because that would affect the cruise control system. So the cruise control system will keep accelerating if the sensor values keep decreasing the speed value. And there can be delayed actuation. Now in delayed actuation, there will be, that's the case if for any reason, either because of an integrity breach or of an availability breach, it takes a long time for information to reach. So if it is about a gas pipeline safety valve controllers, and these take very long to receive any kind of instruction, any kind of information from a computer system, then that can lead to dangerous pressures there. And there can be prevented actuation. An example that I have here is when we have a surveillance robot or anything that needs a battery, for example, a medical implant. If the battery is exhausted, then it can no longer function. So that prevents its actuation from then on. We have an actuation prevention by exhausting the battery. If one suppresses the operation of a car window, for example, if we inject the close command for the car window all the time, or at least every time the open command is normally received, then that window will never open. So we have prevented the actuation of opening the window. And I'll have an example here for you. So I have an example of for hunting for little possible cyber-physical attacks. The setting here is kind of silly in a way, but I think it's useful in order to start thinking about different types of cyber-physical attacks. Is that we have a, let's say, someone of value of well, everyone is someone of value, but someone of value perhaps to a foreign intelligence service agent, so perhaps a politician. And there are these foreign intelligence service agents that are tasked to target the politician's weak heart. They know that this politician has a weak heart, so their aim is to try to target this. The setting is the politician sleeping in their home perhaps, and there is the desk where they have a normal PC with speakers and cameras, so the standard PC. They connect to the internet through a network router, a Wi-Fi router. There is and since the politician has a weak heart, she has a wireless implant which is used in order to help its doctors collect real-time data in relation to the heart operation. And there is a remote monitoring transmitter there which does this transmission. So the remote monitoring transmitter is getting data from the wireless implant all the time or periodically, and is transmitting the data about the health of the heart to the doctors through the network router and then through the internet. So in this scene, what components of the scene might the intelligence service agents try to exploit remotely? And you can of course take any reasonable assumption you want. So you can take any assumption you want about what this kind of wireless implant is. It says there that it monitors and regulates heart. It can deliver a shock if it detects arrhythmia, and so on. So this is the kind of actuation it has. It detects, it delivers shocks if it detects arrhythmia, and there are a number of different types of sensors and actuators around this scene. So my hint for you is that you should try to identify any sensors that are of relevance, any actuators that are of any relevance, any kind of computing, embedded systems, and any kind of network that is in this scene, and try to find different attacks. Okay, so this is effectively homework for you, so you do it on your own, and let's see how many you will get. Now, we talked about the different types of cyber-physical attacks from the perspective of the impact, but we should never forget that the way in which an attack has an impact depends also on the entry point. So how did this attack start? Where did it start from? We're talking, of course, about attacks originating in cyberspace, but in the context of embedded systems, of cyber-physical systems, of IoT systems, where there is some form of control, there are sensors and there are actuators. So this is what makes them different. This is what makes them more interesting, those cyber-physical attacks, in relation to perhaps standard attacks in normal corporate networks or in normal local area networks. So the focus is on electronic controllers that are based on computers and embedded systems. Software processes the measurements that come from sensors, and based on this software and based on these sensors, the parameters of the actuation are determined and are communicated to the actuator, which is instructed to do something based on what the controller thinks is appropriate based on the data received from the sensors. So a cyber-physical attack can have impact in multiple places there. It can have an impact on the actual sensor. So the sensor, or not an impact, so I meant it can have an entry point. It can originate in multiple points there. So it can originate from the sensor. So it might change or delay the values, for example, coming from the sensor. It might originate in the sensor to controller network link. So if the sensor to the controller are linked, are networked, are connected together through a network, then it might be the network that is affected. So perhaps intercepting the information coming from the sensor to the controller might happen on that link and perhaps be modified or delayed or just eavesdropped on. And then you have the connection from the controller or you have the actual controller. So the controller can be modified, it can be compromised if there is any kind of malware on the controller, as was the case in the 1960s film, for example, in the Italian Job film, where it was the software on the control room of the traffic lights that was modified. Or it can be then the link from the controller to the actuator. So it can be the network linking the controller to the actuator, where we have some kind of compromising action. So that all of these would be entry points for this for a possible cyber physical attack affecting the actuation in the system.